Our next speaker is the Chief Technology Officer of New Works Interactive Labs. He is an AWS machine learning hero, and is also the author of the books, Machine Learning with Amazon SageMaker Cookbook, Machine Learning Engineering on AWS, and Building and Automating Penetration Testing Labs in the Cloud. In this talk, he will delve into the benefits and considerations of leveraging cloud computing for generative AI. Everyone, please welcome Mr. Joshua Arvin Latt.
Hello. So can you hear me? So good afternoon, everyone. So I'll just be sharing my screen quickly. And I'm super excited for this session because I'm here to talk about generative AI and cloud computing. And again, even though this is like a 45-minute to 1 hour talk, you'll realize that you'll be able to learn a lot of things in just a short period of time. So there have been a lot of sessions already on AI, and this time the topic would be focusing on cloud computing and how we can leverage that along with generative AI in order to build intelligent systems. So without further ado, let's begin. So before I get started, let me quickly introduce myself. So I am Joshua Arvin Latt. I am the Chief Technology Officer of New Works Interactive Labs. I'm also an AWS machine learning hero, and I wrote the following books, the 3 books. So 2 years ago, or 3 years ago, I wrote the book Machine Learning with Amazon SageMaker Cookbook. 2 years ago, or 1 to 2 years ago, I released my second book. I wrote the book Machine Learning Engineering on AWS, and then fairly recently, I think that was a few weeks ago, Building and Automating Penetration Testing Labs in the Cloud. So as you can see, I have dived deep into the topic of machine learning and security. And the funny thing here is that one of the more relevant tools in the cloud is Amazon SageMaker. So when I was in my journey to build more complex generative AI tools, I was able to utilize my knowledge in Amazon SageMaker. So the first 2 books were super helpful, and it allowed me to build generative AI applications in a really short period of time. Lastly, recently also, I think that was last week, no, I won the Digital Leader of the Year award. So there's 5 of us, and I won the Orange Boomerang Award. So really great win for me and the company, New Works. So here, happy to share with you that these achievements are a result of hard work, and we'll summarize everything that I've learned in just 45 minutes. So now that I've introduced myself, again, these are my 3 books. We'll primarily focus on the first and second one. And towards the last section of this presentation, we'll have probably 4 or 5 slides on security. Because when you're trying to build generative AI applications, security will always play a crucial role in protecting the data and protecting the machine learning model deployed in the cloud. So now, let's start with a quick scenario or quick example. My question for everyone is, have you ever asked an AI chatbot the following question? What is the meaning of life? Medyo malalim, no? What is the meaning of life? So the good thing here is that right now it's much easier to do something like that. There are a lot of chatbots like ChatGPT that can help us answer this question. So here in this example, we have here Amazon Bedrock. Amazon Bedrock is a managed service which basically allows us to access foundational models. And instead of us trying to host our own models, we're able to do stuff quickly and conveniently build intelligent applications. There's already a user interface available in Amazon Bedrock. So here we can see in the screen, we just type in the chat box, what is the meaning of life? And yeah, the chat playground chatbot answered, the meaning of life is a philosophical question that has been debated throughout time. Different people have different beliefs and perspectives on this matter. Some people believe that the meaning of life is to seek happiness and fulfillment, while others believe that it is to serve a higher power or to achieve a specific purpose. Ultimately, the meaning of life is a subjective concept that may vary from person to person. Imagine nyo, AI pa yung nagsabi sa atin what the meaning of life is. So very funny, no? But again, if you really want an answer what the meaning of life is, there's no meaning. We create our own meaning. And similarly, generative AI helps create new content like text, video, images from existing data. Kaya nga generative AI yung tawag kasi it helps create new data from existing data. So earlier, we talked about and asked the AI, what is the meaning of life? This time, let's see anong image yung representation ng meaning of life. So here in the screen, we can see that even if we input text, hindi lang necessarily text yung magiging output when you use a generative AI tool like this. No? So we type in meaning of life, that's the prompt, that's the input, and it was able to produce an image in, let's say, 5 to 10 or 15 seconds. Similar to tools like Midjourney and even chat and even the other tools, you just type in the chat the prompt, the inputs, and it tries to map the appropriate image for it. Again, given that this is a generative AI solution, this image is new. The image has not been created before the prompt was inputted. The machine learning or the AI tool is the solution which converted text into image. So if you haven't tried this out, try this out now because it's super powerful and this is just the beginning. So the past couple of slides, we've been focusing on the meaning of life. What about trying to generate an image of a cat flying with wings? So here, we can see that hindi lang realistic things yung kayang i-produce ng generative AI tools. It can imagine different types of images and it combines different properties like wings, like cat, and it's flying and it's there in the clouds. And you can see that, yeah, that the AI tool is able to generate an image of this one. Let's generate a few more. So earlier cats, no? How about dogs? So yeah, so as you can see, you just type in dog flying with wings and the text prompt is converted into an image. And again, every time you run it, let's say you modify the parameters, let's say you change the seed, and then you run it again, for example, you will see that it will generate other types of images which still answers the original prompt. So baka iba ng image na ma-generate, but again, it's still a dog with wings. There, you just saw in the last couple of slides how powerful generative AI is. And the cool thing with generative AI models, these models can be tweaked a bit in terms of usage, and it can help answer some of the questions and requirements from the non-generative AI space. So before, years ago, majority of the machine learning examples were fairly straightforward. Let's say sentiment analysis, let's say summarization, etc. Let's say A to B. So those simple conversions. Using generative AI, given that those models are super large, you know, the models are super large and the training data is there inside, the simpler examples can also be solved as well. So we won't dive deep into that, but as you can see, you can just type in the chatbot perform some sentiment analysis stuff on these sentences, tag whether they're positive or negative. And even though the generative AI solutions are supposed to generate data, it can still perform the other AI powered actions. So here, we rely on our robots or a machine to create content for us. And there are various tools, there are various frameworks available which can help us with this. So in the next couple of slides, we will share several examples and you will realize the different solutions available which could help you build intelligent applications in the cloud. Speaking of, before we talk about cloud computing, have you ever wondered how to utilize a solution like Bedrock and use it to build applications? So the funny thing there is we demonstrated how generative AI works by just using an existing front end. So that existing front end, that existing user interface is available already in Bedrock. The strength of cloud platforms like, let's say, AWS, Azure, and Google Cloud, they're not really stuck to just the existing front-end interfaces. There are something called APIs, which are basically gateways. They are like doors, which allow us to programmatically run scripts and utilize the magic inside those tools. So even though we used the UI, the user interface earlier to generate images, we can convert that into code, input the same types of prompts, and build intelligent apps within just a few hours. Baka nga a few minutes lang eh. So this is a simplified architecture on how to utilize Amazon Bedrock and again, utilize it along with other services, the other serverless services in AWS. So if this is the first time you've encountered services like AWS Lambda and API Gateway, you can just think of the services as building blocks, where each of these building blocks have their own set of responsibilities. Parang may focus areas, each of these building blocks. Amazon Bedrock, its purpose is to allow us to access the foundational models, the different models which allow us to convert, let's say, text to image, text to text, and basically answer some questions, some prompts from our end. That's the purpose of the Amazon Bedrock service here on the right side of the screen. The one in the middle, AWS Lambda, is a service that allows us to build and run functions where we can write custom logic code. So for those who have used Lambda before, you can just think of it as a container of code. And this code, these scripts, are executed when something triggers it. That something which triggers it would be the data, the different sources of the data, the events. So one example of a source would be API Gateway. From the name itself, it's a gateway. It accepts requests and response. So let's say that you try to access an endpoint, a URL endpoint in the browser, or using Postman, for example. You push some data in, API Gateway, its event, triggers an AWS Lambda function to run, and inside the AWS Lambda, what's coded there would be a script which invokes Amazon Bedrock using an existing software development kit. So this concepts may be foreign to you, but once you build it, you realize, oh, the pattern is fairly easy to remember. You just type in 10 to 20 lines of code, put that inside Lambda, configure API Gateway to trigger Lambda, and after 1 to 2 hours of experimentation, you'll be able to build a very simple text-to-text or text-to-image generative AI application. So wow, within just a few minutes, we were able to learn how to build a super simple generative AI application in the cloud. And the great thing here is we are able to also deal with the cost aspect of utilizing AI models. When you're trying to learn machine learning and AI and generative AI as well, you'll probably think that building and deploying these systems would be expensive. However, if you have a lot of experience dealing with these types of requirements, and if you're able to produce an architecture which is optimal, and if you know the use cases and the usage of the users trying to access the system, you might even be able to build a system with very minimal cost. So being able to architect these types of system is a skill on its own, because once a lot of users are going to use it, you'll realize that a good architecture will help you and your company save a lot of money. So now, that simple application, we can definitely further evolve. The three services, the three components earlier were, yeah, purely back-end. We're literally just passing data to API gateway, pushing it to Lambda, pushing it to Bedrock, and then Bedrock responds to Lambda, and then Lambda returns the output to API gateway. Then API gateway returns the response back to the original sender. If we need a front-end interface for it, we can easily build a simple static web application and deploy it in Amazon S3. So Amazon S3 is a container, is a service where you can upload files. Simplified, no? We can upload files there, but there's a feature in Amazon S3 where you can easily serve serverless websites which never go down. So if you have a static website there, HTML, CSS, and JavaScript, add a bit of React also. Even though we call it static website, there can be some dynamic events happening there, and you can use JavaScript to call the API gateway, thus having you produce a very interactive application. So this setup scales well, and this is a good starting point already. However, there's more, no? We could easily upgrade the implementation further by adding a database. So you could either use a SQL database or a NoSQL database. So for SQL databases, you could either use the relational database service, or if you want to use a NoSQL counterpart, the NoSQL counterpart, let's say DynamoDB, you are able to store, let's say, previous conversations inside those data stores. So again, when we're building generative AI powered applications, we don't build the entire system all in one go. We just build it component per component, given that these components are connected in a distributed nature. It's important that we make sure that the components, say component one, component two, they work together first properly before we keep adding complexity to the overall system architecture. Okay. So earlier we started with a simple Bedrock application where we just use the UI. Now we have more or less a complete system. Of course, the security aspects are not included here, and we will discuss that towards the end of the presentation. And there's more for us because things will become more complex, and you'll see that the second half of this presentation is even more exciting. Thus, we define first what cloud computing is. Earlier, we just literally connected a bunch of things. Even though we're utilizing cloud services, cloud computing is so much more in terms of scope and capability and options. When we deal with cloud computing, we usually just think of a computer just there, somewhere, not in our local vicinity. Servers are basically just computers. And these computers can be run somewhere else. And what we're doing when we're launching a server, let's say an Amazon EC2 instance, to run specific processes, we're literally just renting an existing computer from out there. When dealing with cloud computing concepts and services, it's important to take note that it's not just about technology. There's the financial side of things as well. So when you're launching a server, you also need to make sure that you have studied the financial implications and cost when running or deleting an existing resource. You basically pay for what you use. So in some cases, or in most cases, when you use it properly, you will be able to reduce the cost. And when you're dealing with generative AI systems and applications and workloads, when you know how to utilize the cloud properly, you would be able to save a lot of money compared to running it on premises. Because you literally just rent a server when you need it. So here's a quick example. So here in the screen, we see two intelligent beings. The one on the left is a monkey. Monkey, no? And then the one on the right is a man. Let's assume that these beings are machine learning models. So the monkey is machine learning model 1 and the human is machine learning model 2. The reason why we have that analogy is if we believe in evolution, human evolved from monkeys, no, something like that, no. There are different theories kasi, no, and that's one of the beliefs na the human came from the monkey. And in this analogy, we share a quick example on how fine-tuning works in the case of machine learning and generative AI concepts. So when we fine-tune a model, we basically feed it with more specific data to tune it, to make it better. And this is one of the more common workloads performed when improving model performance. In most cases, given that these large language models are super large, yeah, good comment. No, that's the reason why I said somewhat they evolved from monkeys, because in the evolution chain, no, it's somewhat this example is somewhat simplified. Yeah, so apologies, no, simplified example that man evolved from monkeys. But again, yeah, that's the tree, no, evolutionary tree. So when we fine tune a model, we basically feed it with something which improves it. And there, this operation is very expensive. Because when you have a large model and when you have a large data set, you would need a large machine. If you were to rent a large machine, a very expensive machine for an entire year, and just park it in your on-premise data center or your office, then basically you paid for it, no, the entire time. However, if you are only going to use that machine for, let's say, 6 minutes, or let's say 6 hours, no, then you would just pay for the 6 hours that that machine is running. So as long as you are able to turn off that machine, then you would be able to save a lot of money. At the same time, the more you are knowledgeable about the platform and know the existence of certain features like easy to spot instances, where let's say 70% or 80% of the price per hour is reduced or deducted, then you would be able to maximize things even further. Example, let's say that the price per hour is, let's say, 100 pesos per hour. With spot instances, you would just pay 20 to 30 pesos per hour. If you were to multiply that into 6 hours, that's a significant amount. If you're going to continuously fine-tune and have this type of operation, these numbers and savings add up. Of course, when you're utilizing spot instances for these types of requirements, you have to make sure about the limitations and challenges encountered when using spot instances. There are, of course, caveats when using these types of solutions. However, if you want to get started without using spot instances, that's also possible. Just using the easy to instance by default, and you're pretty sure that it won't turn off automatically. In spot instances, depending on the wave, no, to simplify it a bit, there are times when the demand increases, you might lose the spot instance. So it's about checking the different options that you have along with the different um, requirements and constraints that you have as a professional. Now, the exciting part. So the previous years, I keep asking everyone, can we build an AI-powered application in 24 hours? So the previous years, there's no generative word there. It's literally just, can we build an AI-powered application in 24 hours? Now, I ask the same question, but this time, the word generative is there. Something more complex, something which involves large language models, something which involves more complex scenarios. We will answer this question in the next couple of slides. Because the answer may not necessarily be yes at this point. So let's start with a simple example, a self-hosted large language machine. Large language model. So earlier, we literally just used a managed service where we just do an API call, and then there you go, you have an image or you have text. In some cases, it might be more appropriate to have a self-hosted large language model. And there are advantages to that, which we will discuss shortly. But when you're dealing with self-hosted LLMs, you basically push in a couple of inputs, a couple of parameters, push it into a machine learning service, and then you have an inference endpoint. In some cases, you want to do it the vanilla way, that there's no machine learning service. You launch a server, use some frameworks, and then you run it. You run an inference server which loads a machine learning model. If you haven't tried this before, it is advisable to utilize a mature machine learning service first. And if you want to optimize on costs later on, you can easily replace this machine learning service with its vanilla counterpart, something like EC2, use some Docker containers, and so on. But again, in the examples that I will share here, I will use SageMaker as the machine learning service, which helps us deploy LLMs in the cloud. A lot of people ask me, what do we mean by an inference endpoint? So if this is the first time you've heard about this word or concept, you can just think of it like a website that is purely back end, like a web API. No? So if you have front end, you have back end, you have a back end API. The inference endpoint is that back end API. The input is the request, and the output is the response. The inference endpoint simply accepts the input, which is in this case, potentially a prompt. And then the return would be the response output from the machine learning model. So inside that inference endpoint, the machine learning model is loaded there. And when you're trying to call the inference endpoint, the web API simply invokes and uses the machine learning model to respond to the question. So that's what an inference endpoint is. So what are the advantages of deploying your own LLMs? So number one would be data privacy. So if you have some confidential information, and if you were to utilize APIs, if you were to call an API built by another company, of course you would be pushing your data there. The dangerous thing there is, what if that other company uses the data that you pushed to retrain the model it already has? So the dangerous part there is, things that you are not allowed to share has been shared to an external party. So similar to using something like ChatGPT, it's not recommended to just push the confidential information there in the chat, because a lot of things could happen. Even if there are guarantees, or even if there are things mentioned that they would protect your data. For example, what if that company suddenly encountered a bug which leaked the information to unauthorized people? And that could happen, and that could probably have happened in some of the companies already. So if you have your own LLM, you would be able to keep your data intact, and your users' data would simply run inside your own network, in your own virtual private network in the cloud. The second one would be long-term cost efficiency. There is an asterisk in this item because it depends on your architecture and solution on what cost efficiency you would have. Because it depends on the prompts, your usage of the models, and basically how your intelligent app works. In most cases, when you are just starting, it might make more sense for you to just use existing APIs. However, as your requirements become more complex, you would realize that you would need longer prompts with more tokens, and your output would be longer as well. So as long as you're able to compute this properly, and you have a good idea on how to optimize costs and choose the right architecture and solution, you would be able to unlock long-term cost efficiency aspect when deploying your own LLMs. Number three would be customization. Here, again, I mean, it's fairly obvious. You deploy your own LLMs. If you need it to behave differently, as we will see in the third part of this presentation, you will realize that you can further tweak it to include custom data, not part of the original model. So you have your model deployed in the cloud, and there are different techniques like RAG, which we will discuss later, on how to customize the answers and make the answers more pointed so that your model would hallucinate less. Finally, deploying our own large language models would help us maintain regulatory compliance. Again, similar to the same exact reasons as with point number one on data privacy. So very exciting. Second half of this presentation includes deploying our own LLMs along with some custom stuff where we include the data from PDF files as an example. So you would see a more advanced use case earlier where we just don't rely on existing downloadable open source models. We also include custom data. So yeah, so may teaser na, yes, included ang LangChain sa presentation na to. All right. So when trying to deploy our own large language model in the cloud, again, utilizing a managed service would remove a lot of headache. Of course, there's some overhead when it comes to cost. But when you're just getting started, utilizing these services would help you deal with the more difficult problems. And if you need to utilize some of the features of the managed platform, sometimes it's just a configuration change away, or sometimes it's just 5 to 10 lines of code away. In this example, we have here a large language model in Hugging Face. So we have Hugging Face, they have a lot of models there, and they have prepared a lot of tools and libraries. Basically, it helps us deploy large language models quickly. When you combine that with SageMaker, and when we utilize the SageMaker Python SDK, with just 5 to 10 lines of code, you just select the large language model you want to choose, and you would be able to deploy it into its own inference endpoint. And there, you already have your backend API, which serves as that inference endpoint. So it accepts prompts and it returns the answer. So very simple. However, building an intelligent application powered by generative AI is not as easy as it sounds, because this part is only a small portion of the overall architecture. A lot of the machine learning enthusiasts and learners think that after they deploy a model in SageMaker, that's the end of the story. If you have built AI powered systems in the past, you would know that this part is only 10 to 20% of the overall architecture, sometimes even less. Because you have to think about the other parts also. An example of this would be the user interface. So this one, we have here an existing large language model deployed in a SageMaker endpoint here on the right side of the screen. When you deploy it, you don't have the interface yet. You would need something like Postman, or you would need a library like Boto3 in order to trigger and invoke that service, that endpoint. But to make it a bit more practical for us to do demos, it might make more sense for you to utilize something like Gradio. So you can just search it if you haven't used it before. You can use something like Gradio to help you produce a user interface with just a couple of lines of code. So this one is super useful when you're trying to do prototype demonstrations. So can I get a raise of hands who has used Gradio before? Oh, may isa. Yan. So if there's one person who has used it before, then good. May dalawa. Ayan. So there are two people, no? So feel free to check this, because if you're planning to host your own models, this is going to be super helpful, because you do not want to spend an additional week just trying to produce the user interface. You just need a few hours, maybe copy paste, trigger the model, and then have it used for the stakeholders. Once they have approved your project, once they have approved the budget, then that's the time you build the entire application. And that's what we're going to do now. So similar to the example earlier, instead of Bedrock, the API, being invoked from Lambda, this time AWS Lambda would invoke the SageMaker inference endpoint. And we simply just need to use something like the software development kit, like Boto3, where we just pass in the input from the API gateway and just pass it to the inference endpoint. So the flow is similar. The event comes from API gateway. It invokes an AWS Lambda function, invokes the inference endpoint, and returns it back to API gateway. And then API gateway returns it back as a response to the sender. Again, we may have a front-end UI calling calling requests to API gateway, and then we can of course add a database there to help us store the previous transactions and also include a bit of additional logic to our system. One thing to note when dealing with this type of architecture and approach is that the model deployed in the SageMaker inference endpoint can be updated and replaced using additional or available models. When I say other available models, the moment you, let's say, deploy an open source model, let's say 6 months ago, just wait for a few weeks or maybe a few days, and there will be more competitive and more powerful models that would defeat your previous model. So here, we can see that as long as we know, as long as we have the template to produce something like this, building various types of generative AI-powered applications would be super easy. So what's the advantage of replacing an existing model deployed in SageMaker? For one thing, a more recent and more optimal model could require less expensive servers and perform significantly better than older models. Mas mura na, mas malakas pa. Example, let's say 6 months ago, they released this model. It requires a G5 12x large instance. So medyo mahal yun, no? 12x large. Now, 3 weeks ago, they released a similar model that is more powerful but requires less resources. So instead of 12x large, it became 2x large. So from 12 naging 2. At the same time, it started to accept and produce more tokens. So when I say tokens, mas mahahaba yung mga sentences which are involved when dealing with the model. Again, sometimes it's plug and play. In some cases, a few modifications would be needed. Kasi when you're using a different model, of course, the tokens and prompts may change a bit as well. Sometimes it's a bit, sometimes ibang-iba siya, but of course, you have to learn how the model works. When you use something like SageMaker, a managed service, you are able to utilize the other capabilities and features that can easily be enabled when utilizing that specific service. At the same time, there may be other services which can easily be utilized to work with that service. Again, when utilizing cloud services, you're literally dealing with you're literally dealing with building blocks. So as long as you know what to select and how to connect these services together, you'll be able to produce something amazing. At the same time, you would be able to manage the cost. For example, if you want to, let's say, enable SageMaker Debugger, instead of you trying to build your own debugging tool for machine learning workloads, we can just use the existing one. Some of the services and capabilities here are even free. Parang naka-tuck in na siya dun sa mismong service. So make sure to check the pricing page before you use the services, of course. Now, going back to the question, can we build a generative AI powered application in 24 hours? Yes, we can. If that's the example that we're trying to build. Kasi what we just did is we just selected an open source model available in Hugging Face. You just use a template that's already existing. You just wait for 1 to 2 hours for the script to run. And then boom, you already have your SageMaker inference endpoint. And then you just prepare a front end. Probably that front end would simply have a text area there, an output pane here, and then you're able to connect the dots and produce a very simple application. When building these types of applications, it's important that we know the limitations. The reason why I didn't answer yes right away when we ask ourselves, can we build a generative AI powered application in 24 hours? Sometimes it's not enough. Wow, lalim, no? Sometimes the output or the deliverable that we just produce is not enough before we can consider it something usable or something reliable. When utilizing open source machine learning models and when you're self-hosting those AI models, we have to be aware of the different limitations it has. Kasi literally, dinownload mo lang and you launch it. Number one, the first limitation that we need to be aware of is it lacks when it comes to domain knowledge. These large language models are limited, and there would be other more specific models which can do a specific task. We'll see the different solutions later, but here we're already mentioning that it's somewhat limited. So if you have used ChatGPT before, you would probably be aware that the text it produces, let's say a script, sometimes it's not up to par with what a human could produce. Baka kailangan mo pa mag-feed ng custom data ng previous conversations mo before it can generate text which sounds like you. So similar in this scenario, if you use something raw na dinownload lang from the internet, then yes, it lacks when it comes to domain knowledge. The second one is somewhat related. There's a higher chance of the model hallucinating, that is producing incorrect results. So if you use ChatGPT before, similar, if you search your name there, let's say you search, who is Joshua Lat? Ganyan. If you did not activate, let's say, yung internet access, magugulat ka, naging football player ako bigla, di ba? So, tinry ko yun, and it's kind of funny. However, if your users are not aware that hallucination is even possible, then that's going to be risky. So, even if lagyan nyo ng asterisk doon, mag-hallucinate yan, mas maganda pa rin if the output that we have is more accurate. Third, knowledge is limited to when the model was last trained. So when you're using these types of models, makikita nyo sometimes only up to 2021 lang yung answer. And then if you want to fine-tune it, fine-tuning may be an expensive solution, and you would have to do it, let's say, every week or every month. And it may not make sense to just fine-tune it because it's a different type of complexity. No? Deployment and training, they are two completely different beasts. And fine-tuning, you would have to study it in order to do it properly. Ang daming mga different papers and examples available when fine-tuning different types of models. Doon pa lang, mauubos na yung oras nyo, and you would need a specialist to help you fine-tune models properly. At the same time, when you're fine-tuning models na large, you would, of course, need yung data and yung resources accompanied dun sa workload na yun. So it would be potentially expensive. That said, we would solve this with one of the more modern solutions. So this is not the only solution possible when dealing with the limitations I shared earlier. Every single week, there are more alternatives to this one kasi hindi silver bullet ang RAG, yung Retrieval Augmented Generation. Again, if you know this is much better compared to the raw version we shared earlier. Knowing this and knowing how to utilize this to add customization to your output is of course necessary. But again, let's start with one example. At least this one solves a lot of problems already. So how does this work? Let's say we have several PDF files containing data that's not inside the large language model. Kasi itong PDF na to, it contains proprietary data for your company or maybe data na fairly recent lang, na 2022 onwards. No? So these files, you use that and use Amazon TextTrack, a service, to extract nga, di ba? You extract the text from the PDF, convert it a bit, and push it into a database or a data store. We won't talk about the vector databases and different variations of it, but to simplify things a bit, the information stored in the PDF files would be extracted, transform a bit, yung mga embedding ganyan, and push it inside a face. Gagamitin yung face, isang gawa ng Facebook yan, Meta, and then there would be a database in addition to the large language model that you deployed. And you're going to utilize something like LangChain along with SageMaker and yung database na yun when you're trying to process the input or the question from the user. So this time, when the question is asked, hindi siya diretso sa SageMaker, dadaan siya sa LangChain and may-utilize yung information na nakastore dun sa database, magse-search siya dun and magagamit along with SageMaker large language model na naka-deploy dun sa inference endpoint. Yun. So basically, instead of just SageMaker, we introduce additional components where baka mag-match yung question and answer na mapping doon sa nakastore sa new database. And yung new database na yun, yung data, nanggaling dun sa mga PDFs na in-upload or ginamit earlier. So now, with this solution, we now have a more accurate set of answers, and we can easily add some conditions where if medyo malayo yung answer ng overall system, the system can simply answer, sorry, no, I don't know the answer. So this is one of the possible architectures possible. You can easily replace some of the components here. So madaming mga options dyan, no? So may mga pinecone, yung text track, pwede mong palitan ng something else. But as long as you understand how the process works, you would be able to produce better answers using RAG. Now, let's talk about the last section of this presentation. Wow, diba? We learned a lot of things over the last couple of minutes. I think it's already been 40 minutes, no? Pero yung last 5 minutes natin, mas marami pa tayo matututunan kasi hindi enough yung pag-build ng application na gumagana. This past couple of weeks, we've seen a lot of websites and organizations, even the government agencies, no, they have been compromised. So when you're building an application, it's important na security is discussed day zero pa lang, hindi after the fact. Security needs to be there in place before it gets hacked. Hindi pwedeng ma-hack muna bago siya ma-secure. Dapat habang binubuo pa lang yung application, we're able to secure it properly. So where do we start? Security is a topic of its own. And learning generative AI and software development, software engineering, machine learning engineering, data science, and now, if you're going to study yung mga new concepts ng generative AI, mo-overwhelm kayo. So where do you start? You start with the attacker's mindset. Sometimes you would learn about the different best practices in security by sometimes you would just think na those are enough, yung best practices in security. However, knowing how to attack would teach you how to defend. Sometimes there are two components. One component is closer to the outside and the other component is inside. Medyo aabutin ka pa ng 5 steps bago mo ma-reach yung nandun sa inside. This simplified example, so in this simplified example, we're sure that this entity or component is exposed to the public. So of course, yun yung una mong isi-secure. And of course, layered yung security and different security techniques and solutions yung needed to protect against various types of attacks. Minsan, kakailangan mo pa ng VAPT, vulnerability assessment and penetration testing to make sure that the application and infrastructure is secure. Baka mamaya, ang ganda ng pagkakabuo nyo, tapos may open lang na port, gumamit kayo ng EC2, yung isang website nyo na compromise. Pag na-compromise yun, baka mamaya biglang yung EC2 instance, meron palang nakakabit na administrator access na policy. So yung buong cloud account nyo na-compromise because of an IAM privilege escalation technique. So medyo scary. So in order for us to learn how to secure an application, let's have a quick example. Let's use the example discussed earlier. So earlier, we have this example where we have a large language model deployed in a SageMaker inference endpoint, and we have Lambda invoking it. And we have the other components of the serverless architecture. The first thing we need to do when we need to secure this is, number one, what are we protecting in the first place? So the first one would be the database here at the bottom, and of course, the machine learning model. We also have to protect yung system from types of attacks like yung denial of wallet attack. So when you're dealing with a serverless architecture, hindi lang denial of service yung possible. There's something called denial of wallet. Denial of wallet kasi mauubos yung pera nyo. Kasi binombard ng request, tapos naging sobrang mahal nung babayaran nyo dun sa bill, ayun, kayo yung kawawa. So guys, nakakatawa siya pero hindi yun joke. Kapag serverless yung system mo and you're not able to add the proper guardrails, possible yung denial of wallet attack. And at the same time, the second part there is identifying the surface area. Ano ba yung mga readily available to the attackers? So if it's available to some of your users, it may be available to the attackers as well. So you would have to secure yung front end, yung API gateway. You have to ensure that only authorized users would be able to use the model and so on. So that's how you assess. At the same time, it's best to utilize different tools, such something like yung guard duty. So you would be able to easily detect other types of attacks. So right now, before kasi magbuo ka lang ng matigas na website, matigas na system, enough na. Something na hardened. In some cases, you would need additional solutions which would help you detect and easily mitigate these types of attacks. At the same time, yung VAPT, unti-unti nang nagiging normal siya. And later on, ma-realize nyo na sa mga organizations, yung mga red team, blue team na yan, that will become more standard here in the Philippines. This is the third to the last slide. However, it's important that we spend a few seconds on IAM privilege escalation. When dealing with cloud computing resources, we simply just assume that the cloud is secure. However, when dealing with cloud resources, it's going to be a shared accountability. So if you misconfigured the cloud resources, it still falls on you. So a good example of that, again here, we have IAM privilege escalation. IAM, Identity and Access Management Service. You are able to create users, groups. So iba lang yung concepts and definitions in other cloud platforms like GCP and Azure, but it works the same way. Now, there are users accessing an account. When you have something like IAM privilege escalation, an account or a role with limited permissions can be used to unlock access which it shouldn't have in the first place. So kapag marunong sa cloud IAM privilege escalation yung hacker, yung lahat ng resources mo sa account pwedeng mabura, manakaw, or pwede siya mag-create ng resources which can be used to attack other organizations and companies. And then finally, we have attacks on data privacy and model privacy. When dealing with security of generative AI applications, it's important for us to know na hindi lang infrastructure yung sinisecure. We have to know that there are AI and machine learning related attacks and exploits which are unique to the generative AI space. So this deserves a different talk on its own, and this is being discovered as we go along over the last couple of months. Last year, and 1 to 2 years ago, when I was talking about this in different conferences, sobrang onti pa ng research papers on this. However, right now, a lot of documentation and examples are available online, and there are even tools to detect and protect from these types of attacks. That's pretty much it. Thank you again for listening to my talk. In this talk, we talk about how to build intelligent systems and how to leverage generative AI and cloud computing, and hope you learned something new.
Thank you very much, Joshua, for that fruitful presentation. And I see a lot of emojis from our audience. I'm pretty much sure they have a lot of questions for you. Okay, let's start the first question with Ryanel. Do we still need to train the generative AI made with Amazon Bedrock?
Good question. Okay. In most cases, when you're just trying it out, no need. I mean, majority of the scenarios, kapag proof of concept, you use Bedrock and the available models there to produce and build an application. However, you have to study yung pricing ni Bedrock kasi token-based siya. So kapag yung solution mo medyo mahal pala pag ginamit ng 100,000 users, you have to look for other solutions na may na magbibigay sa'yo ng same output and magbibigay sa'yo ng opportunity to fine-tune yung model. Meron namang option sa Bedrock na fine-tuning, pero usually kapag nagiging complex na yung requirements mo, mag-SageMaker ka na. Pero again, if you have no machine learning engineering experience, Bedrock is a good place to start. Yeah.
Okay, great. We also have another question from JC. What approaches do you recommend for understanding and explaining the outputs of generative AI models?
Yes, so dalawa yung sagot ko dyan. There's an answer to those yung mga nasa may data science background, the ones trying to improve yung model. Basically, ano na siya, machine learning and data science discussions na siya. You're going to use metrics and yung mga explainability aspects in order to understand yung behavior ng model. Kasi syempre, yung model nyo ngayon, after 1 to 2 months, you'll realize, baka kailangan ko palang palitan. And there should be a way for you guys to understand how it works and to understand the performance. There are new research papers. So ito, yung evaluation ng generative AI models, it's still being studied. Meron na mga default answers right now. Pero actually, a few days ago, may lumabas na research paper on how to properly evaluate models. So that's the first answer. The second answer is when you're talking to the stakeholders who will use your system. Kasi in most cases, they will not be as technical as you. Baka mamaya hindi nga nila alam nag-hallucinate pala yung model. So if you're able to explain dun sa mga stakeholders and users ng application mo na ito yung mga limitations, ito yung prompt for that, ito yung mga ethical considerations you have to be aware of when you're using this AI solution, yun yung other half. Kasi it's not all technical eh. It's about the business aspect as well as yung sa product side on the usage of the customers. So, good question.
Thank you for that, Joshua. And for our last question, we have Ryan L. Is generative AI made with Amazon Bedrock a good solution for a chatbot? For example, will this give more capability to the chatbot, knowledge of a product, the company, and more?
Basahin ko lang yung question ulit. Is generative AI made with Amazon Bedrock a good solution for a chatbot? Yes. So short answer, yes. However, if you are a builder, you need to be an architect also. Amazon Bedrock is not the only solution available. Meron din naman ChatGPT API eh. Diba? There are other options available, and before you start building the entire application, mag-proof of concept muna kayo dun sa mga different solutions available. May mga similarities kasi sila. And the answer really depends on the overall solution that you're building kasi right now, yung mga machine learning experts internationally, yung mga co-heroes ko na machine learning heroes, some of them argue that if you're just going to use the generative AI model as is, you might not be trying to solve a real problem. Because you would have to start with a real problem na more pointed yung binibuild mong solution eh. If you are going to use a generic model to solve that problem, baka kulang. Matatalo ka ng more fine-tuned and more specific na solution. So, make sure lang na when you're using a generative AI solution, meron ka dapat option to fine-tune and utilize custom data. Ayun.
All right. Thank you, Joshua, for answering all of our questions. Again, guys, if you have any questions to our speakers, you can still engage with them through Ermit Lounge. And before letting you go, please may I ask for a quick photo op? Just smile in the camera. Okay, 1, 2, 3, smile. Thank you very much, Joshua. So again, let's thank Joshua by clicking our emojis. And also a few reminders to our audience, guys. Please do engage with us through Ermit for a chance to win prizes from PSIA and Globe Business and IBM. This will continue until tomorrow. So We still have a plenty of time to earn points. We will announce the winner tomorrow later afternoon. If you have a hybrid ticket, download the Airmeet app from the App Store or Google Play so you can continue engaging on the app even while you're on SMX. And our registration starts at 7:30 a.m. at SMX Aura. And for virtual ticket holders, live streaming starts at 8:30 a.m. See you guys tomorrow. And well, this is the last session for the day. It has been a great time learning along with you, and I hope to see you all tomorrow. Bye, everyone. See you at SMX Aura.